Alright, welcome everyone. Today we'll be going over some basic pre-calculus concepts that I personally think were very important for me, going through class and calculus as well. Today we're gonna begin the trig unit. So, trigonometry is almost essential. While the idea of triangles themselves aren't that used much, these trig functions, sine, cosine, tangent, are used in almost every unit. Like every single problem you do, or every single type of problem you do, there will always be a way to work in these, and also incorporating. Oh, and one thing you need to keep in mind always is that when you use a calculator for these types of problems, remember to use radians instead of degrees. This is really important because most of the time most of the values that you're gonna use will be based using pi. You guys have seen the unit circle before, right? All right, here's the unit circle. It's like 0 here. At 45 degrees, we got uh 2 square root of 2 over 2, and then here we got 1 0 1 1 0. All right, so most of you have seen this, right? Like this just means sine of 0 equals 0, cosine of 0 equals 1, and vice versa for like all the units on the unit circle. You can just find it easily if you look it up. But that's not what we're gonna cover today. First, we need to introduce these new topics that have been introduced to us in pre-calculus. All right. We're gonna start with the so we have sine here, cosine here, and tangent. You've definitely seen this before if you've gone through like algebra 2. You've probably had to use it a bunch of times, but what if you saw uh cosecant? Oh, that's wrong. Sorry about that. Then we have secant here, then cotangent here. And these can also be written as uh arcsine. Arc tan. And you might be like, yo, what are those new things? But these are essentially different names for what are just the inverse of a sine function. Tangent inverse. All right. So you all know what an inverse function is, right? You have a y. Let's say this equals 2x. Oh, let's erase everything first. Let's do a quick review. All right. Let's call this y equals 2x. Graph of this looks something like this, right? Now, the inverse of this is that we switch the x and y values. So on here, it would be 2y, and to graph this easier, we convert this into, we turn this into, to define for y, which is y equals x over 2. Y equals x over 2. Now the graph of this is this. Oh, no, that's wrong. Sorry, my bad. All right, let's redraw that. Now it looks like this. This is at 0. Sorry about my really bad handwriting, guys. So essentially, the coordinates for this are 1, 2, but the coordinates for here are 2, 1. The main point of this is that when plugging in the values, the x and y values get switched. Alright, so now going back to the trig functions. Right. Let's take sine of pi, for example. Sine of pi equals 0, right? We can, uh, sine is just a function. It's no different from calling it f of x equals x or 2x or something like that. In this case, the x is pi, and the y here is 0. So the graph of sine looks like this, right? More something like do do do, right? And so on and on. Arrows pointing out to each side. Right. Now we go here. So let's at pi here. This is where pi is. Now you see here that it intersects 0 here, right? So y would be 0. But the inverse of this, when you means that sine inverse of 1 of 0 equals pi now. So graph of, instead of being here, this would actually just be here. Because the x and y values got switched, you see? It went from pi 0 to 0 pi when you took the inverse of it. You don't have to understand this all now, but this is just like a more visual representation of the concepts. And once you actually get into solving the problems, it doesn't really matter as much in terms of how you think of them. So back to the topic, right? So we have sine here. A common notation that you definitely need to know is cosecant for sine. And for cosine, secant. And for tangent, cotangent. All right. Essentially, oh, by the way, another way you can think of them is just 1 over sine. Because that's honestly all you need to know to understand them. Same for here, 1 over cosine. 1 over tangent. All right, so for these, essentially, most of the time you just interpret these as the reciprocal of sine. Last time, sine minus 1 were the inverses, but these are now the reciprocals. Oh, and another thing, tangent is sine over cosine, right? So in here, if you flip over sine, if you flip over tangent, it becomes cosine over sine. Right. So let's look at an application problem for this. All right. So here we have, say, sine of x times uh, cosecant of x. What is the answer here? Well, this is really simple, but because we determined that cosecant is just a reciprocal, this is sine of x times 1 over sine of x. So these just cross out when you multiply them, so it just turns out to be 1. And this is going to be a really important concepts when you get to like more complicated equations, like say we have something like cosine, sine, tangent, uh yeah, cosecant, all right. Cosecant of x, tangent of x, sine of x, cosine of x. All right. Here we have cos x, then times sine. What you want to do is that you want to like write out tangents so that in case you can simplify them. So here it's cosine over 1 times sine over 1 times sine of x over cosine of x. And here is 1 over sine of x. All right, so if we were to multiply this out, sine x cancels, cosine x canceled. So, oh, wait, that's wrong, sorry. All right, sine of x cancels here, so what we're left to it is just cosine of x, surprisingly. All right, you all got that, right? So when you solve these problems, just make sure to simplify them out. And when you get to more advanced math, you need to understand something called identities. To start it off, let's start with the Pythagorean identities. Pythagorean as in like the Pythagorean triangle, like a squared plus b squared equals c squared. All right. So the base equation for all of these equations are sine squared theta. By the way, theta is just an angle or radians, but we're just writing it as radians instead of x to make like to show the fact that it's not just like a coordinate. It's easier to see in this situation, so that's why we're using it. Cosine of theta equals 1. Yeah, yeah, take that in. Take that in. This is one of the most important equations. Like every single other identity is somewhat related to them in some way or manner. At least all the hard ones are. All right. Uh, applying what we learned earlier with like the whole the art secants, cosecants, and cotangents being reciprocals, we can see it here. So sine squared theta plus cosine squared theta equals 1. What happens if we divide both sides by sine? Let's try doing it, right? We divide every single object on here by sine squared theta, right? Sine squared theta, sine squared theta, sine squared. All right, what happens to here? Sine squared theta crosses out, so it becomes 1 plus cosine squared over sine. What did we say cosine over sine was? Cotangent. So this here is cotangent squared theta. And what is 1 over sine squared theta? That is cosecant squared theta. And yeah, this is it. Essentially, these identities are gonna be useful when you get problems, and you just simplify them into other forms so that you can like back in like the fraction ones, you need to be able to like move them into forms in which you will be able to like adjust them so that you can like mold them around, cancel them out, and more. Right. Same application as this one. Let's try dividing everything by cosine this time, right? Right. right? Divided by cosine, well, cosine squared theta, cosine squared theta equal, and then cosine squared theta. All right, this becomes tangent squared theta. You should know why. Plus 1 equals secant squared theta. And sometimes the 1 on here gets moved around to be like tangent squared equals secant squared theta minus 1. This is just to like make sure that you're solving for a tangent. So don't like just move it around if you don't really recognize it first. Like these whole concepts are based around just simple division because every every trig function like leads back to each other. Like because they're all functions that are related to each other. Most of the time, if you can't seem to solve it, if you move them around and try to cross them out, you'll find a way to solve it. Like 98% of the time. All right. Next concept. What else? Oh, all right. Actually, this might help you visualize. All right, let's go see the graphs of uh, these weird reciprocals of the trig functions. All right, let's go into Slater. No, no, not Slater. Online graphing calculator. Yeah, Desmos. I forgot about the name. All right, I'll pull this up on the stream right here. Let's. Actually, we don't need to close that out. Right. All right, you can all see what it is on Desmos, right? So let's look at graph of sine of x, right? Simple. We've all seen this before. Starts at 0, hits 0 again around pi, and keeps going on infinitely. It never gets bigger, and it's it has a domain of negative infinity to infinity, and its range is from negative 1 to 1. Right. Cosine of x. You've also probably seen this one. It's the exact same as the sine graph, except that it's pushed back by around like pi over 2, and now it starts at 1 instead of starting at 0. Before we cover tangents, let's finish covering the sine of x first. Right, so cosecant x. Yeah, so you know how I explained that they were the reciprocals of sine of x? Alright, so if it's tangent, I mean, if something's a reciprocal, it's gonna be 1 over something, right? But at the point when it's 1, it's still gonna equal 1, right? So if something is if sine over x is equal to 1 at pi over 2, cosecant of x is also going to be equal to 1 at pi over 2 because it's just going to be 1 divided by 1. When you draw the graphs, just keep the lines like you see where it touches 0. Yeah, cosecant x can't ever go there. It just has like goes on infinitely upwards, but it never reaches the places where sine of x hits 0. So just draw big hoops, like big u's and like big negative u's from the peaks. Same thing with cosine x. and secant of x. Right. You see here that it has a it meets at 0, right? 0, 1, and then it hits whenever they overlap, whenever it's pi or 0 or 2 pi. Essentially, whenever uh same concept as before. Shouldn't be too hard. But now you get into tangent of x. Oh, tangent of x. All right. So further graph than before, but also probably seen this before, although maybe not as much. Just to go over, different from all the other functions in the graph tangent of x. One loop, like one loop is only pi instead of 2 pi. Just try to remember that. So cotangent x. Yeah, a lot weirder, isn't it? Yeah, so essentially you need to remember that they intersect when they equal 1. Even though tangent doesn't equal 1 at like a clear number, like unlike sine or cotangent, at pi over 4 it hits 1, and it goes the same for cotangent x. Essentially, in terms of understanding this, it's kind of similar in a way, but just remember that instead of doing the curves this way, just draw the curves the other way and have a vertical yeah, and instead of having 0 0, it has infinity here and negative infinity here. All right, that's it for the visualization. Just a reminder, today is just like a quick like crash course intro into everything. So if you don't get it right now, it should be fine. We're gonna cover more in further days. Just a reminder, today is just like a quick like crash course intro into everything. So if you don't get it right now, it should be fine. We're gonna cover more in further days. All right. Oh, all right. Let's also cover this. All right. Unit circle, right? This is this. This is this. But did you also know that uh the value of cosine is essentially equal to the coordinates of x on the unit circle? So cos is equal to x, and sine is equal to y. The value of cosine is essentially equal to the coordinates of x on the unit circle. So cos is equal to x. Right. That's why when sine is equal to pi over 2, it's 1 here, and when cos is equal to, meanwhile, while cos is equal to pi over 2, the x value here is 0. So 0, 1 makes sense, and when cos of x is 0, cos equals 1, which is x is 1, but when sine is 0, y equals 0. So here, 0, 1 makes sense, and when cos of x is 0, cos equals 1, which is x is 1, but when sine is 0, y equals 0. So here. Oh, and another thing. Do you guys know which so applying this concept, you gotta know what the value will be. So you know that this starts at 0 and loops back to 2 theta, I mean 2 pi, right? With it being pi here, just goes around in a circle, on and on and on. But applying this like graph, like think of it as like a just a normal xy graph. When is cosine positive? Like when is the x value positive? The first and the fourth quadrant, right? The first and fourth quadrant, uh, the x value is always positive. Otherwise, it wouldn't be on the first and fourth quadrant. Meanwhile, for sine, when are the values positive? 1 and 2, because if it goes under here, y is negative. If it goes over, then it's positive. So this is positive here. negative here, x is negative here, y is positive here, and here y is both negative and x is also negative. Alright, so applying this concept, y is both negative and x is also negative. Alright, here we come to the, alright, here's where we introduce the even and odd identities. So applying this concept, let's keep this here to make it easy. Alright, here we come to the sine of negative. The even and odd identities inside the parentheses. What do you think this this equals to? Did you have a second to think? Well, the answer is that in this case, this can just be applied outside. And you might have thought, what? That's obvious. You're taking the function of a negative, so it's always going to go to the outside. But that's not actually true, because in cosine of negative theta, it actually equals cosine of theta. So it's always going to go to the outside. But that's not actually true, because in cosine of negative theta, it actually equals cosine of theta. Alright, so the reason for this is because we go back here, right? When sine equals negative, let's say our value is pi over 4, right? The reason for this is because pi over 4 is like somewhere around here. It's here, right? What's the value of x and y here? Our value is x is pi square root of 2 over 2, and the other thing is also square root of 2 over 2. In this case, they're equal, right? What's the value of but if you make this negative, what? Where are we on? When you make the x value negative, you go backwards. So you would be here. Now where are we? But if you make this negative, the coordinates for this point are when you make the square root of 2 over 2 and negative square root of 2 over 2. Now where are we? We mentioned earlier about how sine is the y value and cosine is the x value, right? Even if you go here, because you just go backwards, the x value doesn't change. So in this case, even though you've put in negative x into the cosine, it actually is no different from the answer you would get if you plugged in cosine of theta. The x value doesn't change. So in this case, even though you've put in negative x into the cosine, it actually is no different from the answer you would get if you plugged in cosine of theta. All right. I think that is where we will leave off for today. We're gonna continue on this later, and probably in the next class, we're gonna try to solve some more problems on this. But for today, that's gonna be it. Have a good night, everyone. That is where